Hello, my name is Erin Keating. For this project, I will be discussing the topic of heavy timber construction. Wood is already widely used in low-rise buildings and residential projects. However, the use of heavy timber is becoming more popular as a replacement for steel and concrete. The two main types of engineered wood is glue-laminated and cross-laminated timber, also known as CLT. In glulam, structural milled wood is layered and glued on top of each other and in the same direction. Layering and joining individual pieces of lumber together significantly increases the strength. Glulam performs very well as structural columns and beams. Because of the natural properties of wood, glulam timber can be produced in a variety of shapes and sizes and can also be curved, creating very unique structures. CFT is very similar to glulam, except the layers of wood are glued at 90 degrees to the adjacent layer, providing strength in both directions. This is fairly recent technology. It was introduced in Australia in the 1990s. It is a very good replacement for concrete because its strength and longevity. They are often used for walls, floors, and roof systems. Similarly to glulam, CLT panels can be manufactured to meet the specific needs of a project and can create unique aesthetics to each project. The use of wood has been America's original building material because it was easy to source and assemble. Steel and concrete became the dominant form of building material during the Industrial Revolution. Steel actually accounts for about 90% of the metal produced in the world. Simple wood frame construction mostly is used for low-rise buildings and single-family homes. Today, we mostly see the construction of steel buildings. However, this is beginning to change as the world and the industry is seeking to build more sustainably. More and more urban buildings are being built entirely out of wood. Europe and Canada are at the forefront of this revolution, while the US is slow to adapt. Slowly but surely, however, we are seeing more and more US projects being built out of wood, and this trend will only continue. These are the benefits of using wood as a construction material. They include fire safety, seismic performance, natural insulator, strength to weight ratio, sustainability, prefabrication, durability, and good for the body and brain. Fire safety is extremely important for any building. All structural building materials have negative consequences when exposed to fire and high temperatures. Steel buckles, concrete spalls, and wood burns. The International Building Code considers these three factors when determining fire resistance. These include structural resistance, integrity, and insulation. Structural resistance is the duration of time that an assembly can support its load during a fire. Integrity determines whether the assembly can prevent the spread of flames and gases. And insulation is whether the assembly can prevent the temperatures on surfaces not directly exposed to flames from rising above its pre-fire temperatures. Timber is combustible material, however, it burns in a very predictable way. Timber is unique in that the outer layer will form a protective charring. This increases the likelihood that the structural inner core remains unaffected. New high-performance timber products are even more fire-resistant, more cost-effective, and stronger than ever before. Research shows that a timber product not only meets all safety and fire protection codes, but it often surpasses them. In a fire test, a 7-inch thick CLT wall assembly lasted 3 hours and 6 minutes, which is an hour longer than code requirements. This is clearly fairly significant. Wood has several properties that allows it to perform well during earthquakes. Wood is inherently flexible, therefore it can withstand high loads for short periods of time and retain its elasticity and ultimate strength. Wood frame buildings are typically lighter than those made out of steel and concrete, which reduces the inertial seismic forces, which are inherently more extreme for heavier structures. Timber structures have ductile connections, which allows them to respond to seismic movement without fracturing or causing critical failure. Of course, building codes specify minimum fastener requirements, which benefits the performance during an earthquake. Numerous fasteners and connectors used in wood frame construction offers multiple, often redundant load paths, which reduces the likelihood that a structure will collapse if some connections fail. The thickness of a mass timber determines the component stiffness. Heavy shear walls, which are often CLT panels, can resist lateral distortion, which is common in earthquakes. Wood is a natural insulating material because its cellular structure the cellular structure consists of many air pockets. Wood has an R value that is 20 times greater than that of concrete and almost 200 times greater than that of steel. Unlike steel and concrete, wood does not require a thermal break between the structure and exterior envelope. These buildings can also benefit because wood can store solar heat energy during the day and release it at night, thus reducing energy loads. Additionally, because of the precise nature of the manufacturing process, there is very little air leakage within the building envelope. These characteristics are also very beneficial for natural sound dampening. Engineered wood is lighter than steel and concrete. Its strength-to-weight ratio is 20% higher than steel and 4 to 5 times higher than non-reinforced concrete. So this is an excellent strength-to-weight ratio. Since glulam can be manufactured in a variety of shapes and sizes and curvatures, it allows for immense design freedom and flexibility. I think that many of the most interesting and aesthetically pleasing buildings are ones where the structure is highlighted and becomes part of the architecture. So there's a strong connection between structural design and architectural design, and designing with wood can improve this connection. New technology such as CNC routing has also allowed for more innovative and unique designs with engineered wood. Engineered wood is manufactured to meet specific performance criteria and is very predictable, which provides peace of mind during the design and construction. The first key benefit to using wood is its ability to absorb and sequester carbon, and this carbon remains stored in the building material. A unit of dry wood is actually 50% carbon, which was taken from the atmosphere and replaced with oxygen. The cycle continues when new trees are planted to replace harvested timber. CLT wood efficiently utilized fast-growing, small-diameter trees so they can be replaced faster. A Yale University study in 2014 determined that building with wood could reduce annual global emissions of carbon dioxide by 14 to 31%. Second, the process of producing wood products generates fewer greenhouse gas emissions than other structural building materials. Cement produces a total of 5 to 6% of global emissions, and steel beams require 6 to 12 times more fossil fuels than producing engineered timber. At the end of the building life, the wood is either reused in a new project, composted, or used as fuel, as long as the wood is not left to decompose or undergo anaerobic decomposition, which produces methane. It is very important that the wood for manufacturing be sustainably sourced so that new trees will grow and store more carbon and continue to protect ecological integrity. Worldwide, about 26 billion metric tons of carbon is stored in trees, so we need to keep our forests healthy. A chain of custody certificate ensures that product has been sourced responsibly. Some building projects can take advantage of location to source their wood supply from a nearby manufacturing facility, thus reducing transportation and emissions cost. Prefabrication is a process that allows large building assemblies to be built off-site in a controlled environment and then quickly assembled on-site. Glulam beams and columns and CLT panels can be fully manufactured before reaching the job site. This allows for a quick and easy installation. Research indicates a 25 to 30% improvement for on-site construction time, which lowers cost, decreases waste, noise, and traffic typical on construction sites. Prefabrication also allows the on-site assembly to take place during all types of weather. Durability is defined as the ability of a building or any of its components to perform the required functions over time without unforeseen cost for maintenance or repair. Wood has many durability properties, which makes it desirable in a building application. Wood is resistant to high relative humidity and to many of the chemicals and harsh conditions that often negatively affect steel and concrete, such as corrosive salts, diluted acids, and sea air. Because of these natural properties, wood is ideal for industrial buildings used for chemical storage, cooling towers, or indoor pools. The key to increasing the longevity and durability of wood building is proper design and detailing that manages moisture control and insect and pests. The study between 2000 and 2003 found that many buildings in North America often never make the 50-year mark, regardless of material, because of changing needs and increasing land value. Overall, wood buildings have the longest lifespan, indicating they are more than capable of meeting a building's life expectancy if well designed and planned. According to the U.S. Environmental Protection Agency, the average American spends 90% of their time indoors. So it's clear our indoor environments have a role to play on our overall health and well-being. There has been numerous studies that correlate positive health effects from having natural material in our homes and offices. Research has found that the visual presence of wood indoors can create similar health benefits as spending time in nature. This means reduced stress for the building occupants, thus reducing the risk of high blood pressure, increased heart rate, and a weakened immune system. These buildings also contribute to an improved occupant experience and overall increased productivity and faster recovery time for patients when used well. When used well, timber creates buildings that combines many key aspects of nature connecting design, such as natural light, airflow, and views of natural elements. This is also known as biophilic design. Proper moisture management and pest management needs to be implemented to keep the structure in good condition. In areas with termites, termite barriers, proper foundation detailing, and other precautions have to be taken. Still, many building codes limit the use of wood to 4 or maybe 5 stories. Regulation will eventually catch up to the engineering to further encourage wood use and innovation. For decades, engineered timber has been made with formaldehyde resins, so they do produce a very low emissions, which is not ideal. And new engineered lumber products are becoming available with formaldehyde-free polyurethane resins. There is a limited number of engineered wood fabricators in North America, especially for CLT. With time, increased demand will increase production. If manufacturing is far from the building site, transportation costs and emissions do play a factor. There is a lack of information to run a thorough life cycle assessment. There hasn't been a thorough analysis of carbon emitted by mass timber production because it is enormously complex to track the factors that produce CO2 in forest ecosystems and in production. Some of the data needed is incomplete or absent, and it is unclear how long the wood will be in use. To conclude, like I mentioned earlier, it is so important to use wood with sustainable forest management. Otherwise, we are simply clear-cutting our forests, which diminishes all the benefits associated with using wood and also creates biological deserts and habitat loss. To fully understand the potential impacts of the increased use of mass timber on climate, we need more detailed research and analysis. And to conclude, laminated wood technology is well established, but it is just beginning to take off, especially in the United States. And as demand increases, so will the supply chains and availability of these products. These are my references, and that's all.